Today's lesson is going over the three types of quadratics that we've been looking at throughout this whole January so far. So far we have seen factored form, which looks something like this. I have two sets of parentheses, maybe two different numbers, maybe the same numbers. Standard form, we always have an x squared plus another x, or a regular x, minus or plus a number by itself. And vertex form is going to look something like this. We have parentheses squared and then plus or minus a number. So the difference between all three of these is not a lot, but factored form, mathematicians decided, well, we might as well be blunt with our naming for functions. So for this one, factored form, if I was going to write something about it, what I could say is factored form is the equation before our standard form. So what this means is if I factored this out, right, x times x would give me x squared, and then I'd have a negative 2x, and then a positive 4x, and then a negative 8. If I factored this out completely and combined with like terms, what I'd get is our standard form here for each of these. If you tested all these out, that's what you'd get. So, factored form, think about it as before we FOIL or distribute, that factored form is what's going to also be our standard form, just before you factor it out. Our standard form is the equation that we're going to be using throughout to graph parabolas. And if you wanted to write this in a different way to help you remember, that's totally fine. Remember, these are your notes. And vertex form is kind of straightforward. Remember, we said mathematicians are very blunt and, straightforward thinking of people. So vertex form is going to help you find the what? The vertex, yeah. So take a brief moment, pause the video, make sure you get those down. If you think of something similar or phrase it different, remember, that's okay too. So now what we're going to do is actually go and see each of these equations. So what we're going to do for this is we're going to put all three of these formulas into standard form. We're just choosing standard form because we want to be specific and we want to make sure you guys know how to put it into standard form. So the first one here, I'm going to do f of x equals 5 plus 3x plus x squared plus 2. So remember, when we're combining like terms, we're only combining the ones that are similar to it. So in this case, I have an x squared. Well, I don't have any other x squareds. And x squared in standard form will always be first. So that's our first one here. So we have x squared. And now I'm going to combine any x's, regular old x's, no x squareds. And I have one here, 3x, but I don't have anything else. So that's what's going to come next in our equation. Since it's a positive 3x, we're going to put plus 3x. And our last step here, we have 5 and a positive 2. So what I'm going to do, since those are coefficients, they don't have any x's, they're just left alone, I'm going to add them together because 5 plus 2. So I have 7. So in this box up here, you're going to write x squared plus 3x plus 7. Now let's try g of x and see what we get. we have g of x 16 minus x minus 2 squared. So this is in vertex form, and we're going to turn it into standard form. So the first thing we need to deal with is our parentheses, this x minus 2 squared. So remember, if there's a squared here, it means that there's two sets of this x minus 2. Because look, if a mathematician wrote something out like this, if I bring everything down, this doesn't look nice. It looks pretty messy, and mathematicians like to be firm and have everything easily readable. So instead of saying 16 minus parentheses x minus 2 and parentheses x minus 2, they can say 16 minus parentheses x minus 2 squared. It's a lot faster to say. So now I'm going to start foiling. I'm going to take my first two terms here, multiply them together. And then I'm going to take this x minus, take the x and multiply it by 2, negative 2, which is going to give me a negative 2x. And if I take this negative 2 and multiply it by this x, I'm also going to get a negative 2. But I also need to take that negative 2 and multiply it by this negative 2. And two negatives give me a positive. So remember, this is still all in parentheses. So now what I'm going to do is I'm going to combine like terms and then deal with this negative out in the front. So I know two negatives are going to give me more negative. Negative 2x and a negative 2x gives me a negative 4x. And I can't really combine anything else, so I'm just going to bring everything straight down. So now here comes the interesting part. This negative sign actually has to be distributed into our parentheses here, because remember, anything on the outside needs to be distributed. So we factored and foiled the x squared, so that way now we can deal with this negative 1 out in front of the parentheses. So what I'm going to do is I'm going to distribute it to every single one of them. So essentially, all I'm doing is changing the sign in front of our problem here. So I have negative x squared, and then I have a negative and a negative make a positive, and then a negative and a positive make a negative. Now I can combine like terms. Remember, x squared will always be in front, so we don't have any other x squared, so we're going to leave it as is. Then I'm going to combine any of my regular x's. Looks like I only have a positive 4x, which is totally fine. So I'm going to make sure I bring down my positive 4x. And the last part here, I have 16 minus 4. 16 minus 4 is going to give me a 12. So now I have negative x squared plus 4x plus 12. Alright, so now let's do the last one here, h. Oops. So we're just putting these into standard form. So again, what we're going to do is we're going to distribute or foil. We're going to take the 5 and multiply by the x. 5 times x is just 5x. And then we take the 5 and multiply it by the negative 5 because we have to make sure we do everything in one parentheses and then the other as well, which would give me a negative 25. Now we have a negative x times a positive x. That's going to give me a negative x squared. A negative and a positive give me a negative. And then two negatives actually give me a positive. X times 5 would give me 5x. So again, start with your x squareds. Remember, you can use different colors too to help organize everything. I would highly suggest it. So I have negative x squared. Now combine your regular x's. So I have a 5x and a 5x. Since they're both positive, I know my answer is going to be positive. 5 plus 5x is going to give me a 10x. And then, as I can see, as I put boxes or circles around other things, I can see that I don't have any more items to combine. So the coefficient is going to be left there. So remember, you can pause throughout this video to make sure and rewind to go back to the steps. So now that we put these into our standard form, what we're going to do is open Desmos, and I've got Desmos right here. Make sure you just go to desmos.com and don't click anything down here. It says let's learn together. Click the graphing calculator. This will be able to give us the graph so we can totally graph it. Alright, so what we have now is, I'll zoom in a little bit for you. So now what we're going to do is we're going to find a feature on these graphs, meaning something that they have. So I think we're going to do if it's concave up or down. So what we're going to do is take our equation, so x squared plus 3x, and if you don't know how to make that squared, hit shift 6 and it'll go up, and then you can add the 2, and then you'll be able to add the rest. So now I entered this first equation here. I can definitely see that it's concave up, right? It's facing up. So my feature of my graph is concave up. And what actually tells you if it's going to concave down or up, it's super cool. We actually look at the x squared to determine if it's going to be concave up or down. So in this case, this is a positive x squared, meaning it's going to concave up. That's why it's concave up. I can also tell you what the y-intercept is without even looking. So the y-intercept is actually the last number right here, our coefficient that is completely alone. So where it hits our y-axis, or where our y-intercept is, oops, our y-intercept is going to be 0, 7. This is concave up, and the y-intercept is 0, 7. That's going to be our y-intercept. And if I look over here on my graph, boom, we were right. So now look at the second one here. Do you think that's going to be concave down or concave up? Well, the negative sign in front of it tells us that it's going to be down. And it's going to hit the y-axis at a positive 12. So I know that this is a concave down. And my y-intercept is going to be 0, 12. And if you didn't know this, that's okay. Remember, we're just learning this, and this is, I just want to let you in a little secret. So when we ask if it's concave up or down, or what the y-intercept is, you can instantly tell those based on the standard form. So as you can see, 0, 12 would be our y-intercept. Now graphing the last one here, I have negative x squared, meaning it's going to be pointing concave down, oops, plus a 10x minus 25. So this one we might have to zoom out a little bit to see where it's going to hit on our y-axis, which, boom, 0, 25. So this does work out for everything, right? It's concave down and the y-intercept is 0, negative 25. How interesting. So now you know the basics, how to put it into standard form, how to graph it. Remember, Desmos is your best friend at this point, especially for parabolas. But other than that, we're going to continue on next week in learning about concave up, concave down. We're going to move into more more distributing and standard forms, so get ready.